In this tutorial, we will cover Chapter 7, which is Continuous Probability Distributions. In the last chapter, we covered Discrete Probability Distributions, and for this chapter, we will cover Continuous Probability Distributions. The learning objectives of this chapter describe the characteristics of a normal probability distribution. In fact, this is the only distribution. There are other continuous distributions, but the normal distribution is the most important probability distribution in statistics. That's the only distribution we will consider in this chapter. The second outcome is to describe the standard normal probability distribution and use it to calculate probabilities. The normal probability distribution, there are many normal distributions, but there's only one standard normal probability distribution. For the standard distribution, we have tables where we can calculate probabilities, and we will learn how to calculate probabilities for any normal distribution by using the standard normal distribution. The normal probability distribution, of course, is a continuous distribution and has the following properties. The graph for the normal distribution is bell-shaped, and it's in the shape of a bell, and has a single peak. The peak here is the maximum at the center of the distribution. The distribution is symmetric. We considered symmetric distributions, and we said in this case you will see that the mean equal the median equal the mode. The normal distribution will be symmetric. It is asymptotic, meaning the curve approaches but never touches the x-axis. We'll explain what that means when we look at the graph. Asymptotic comes from asymptote, meaning the graph, the tail of the graph will get closer and closer to zero as x approaches infinity or as x approaches minus infinity. It is completely described by its mean and standard deviation. So for any normal distribution, that's the two values you need. You need to know the mean and you need to know the standard deviation. That completely describe the normal distribution. Because those parameters can be different for different distributions, the mean and the standard deviation are just parameters, but there is a family of normal probability distributions. If you consider a different value for the mean or a different value of the standard deviation, you end up with another normal distribution. So there is a family of normal probability distributions. Another normal probability distribution is created when either the mean or the standard of deviation changes, or both, of course. Here is the graph of a normal curve. As you can see, it is bell-shaped. It is symmetric around the vertical line through the peak. The peak here, at this value you have the mean equal the median equal the mode. These three values are equal, and we know what that means. That means the graph is symmetric. That vertical line through the mean splits the graph into two equal halves. Now to the right, what we are calling the tail, this continues as x increases, as the x values increase, the tail gets closer and closer to zero. And that's what we mean by, here the x-axis is as an asymptote, meaning the tail will get closer and closer to zero as x approaches infinity. The same thing happens to minus infinity. As x approaches minus infinity, the tail will get closer and closer to zero. Of course, we already said there is two parameters that determine the normal distribution. These are the mean and the standard of deviation. For different means, you will get different normal distributions. The same thing for standard of deviation. If the standard of deviation changes, then you get different normal distributions. Here are some comparison for some normal distributions. The first graph to the left, there is 3 distributions. They all have the same value for the mean. The mean is equal to 20 years, but they have different standard of deviation. The top graph is 3.1, the middle graph is 3.9, the lowest graph is 5.0 years. Since they have the same mean, they're all centered at the same location, and the mean is the same, but because the standard of deviation is different, the spread of the data is different, for the width of the bell shape graph is different. So here is comparison now between 3 different normal distribution that have the same mean but different standards of deviations. The graph in the lower part of the screen, here you have 3 graphs, 3 normal distributions that have the same standard of deviation. Standard of deviation is 1.6 grams for each of the graphs. So you can see that the general shape or the width of the graph is the same, but because they have different means, they're located in different places. For the one to the left, the mean is 283 grams, the middle graph is 301 grams, and the one to the right is 321 grams. Here طبعا sigma is the same, for the spread of the data is the same, but the location of the mean is different because they have 3 different means. طبعا it is possible to have both the mean and the standard of deviation different, and that's in the graph in the top right. You have 3 normal distributions with different means and different standard of deviation. فطبعا you can see the location of the mean is different for the 3 graphs, and also the spread of the data, the width of the graph is different for the 3 normal distributions. The one to the left have mean equal to 2000 psi and standard of deviation 41. The graph in the middle have mean equal to 2107 and standard of deviation 52 psi. The graph to the right has mean equal to 2186 and standard of deviation equal to 26. For different means and different standard of deviation. Now the standard normal probability distribution is a special distribution, but we will see why it's special. By definition, the standard normal distribution has mean equal to 0 and standard of deviation equal 1. For this normal distribution, the standard normal distribution, we have tables where we can calculate probability, and we will see now we can take any normal distribution and use the tables for the standard distribution to calculate probability. Now to do this for any normal distribution, to get the probability for any value, you have to convert it into what we call a z-value. These are the values for the standard table that we can use to calculate probabilities. So here is a definition of a z-value. The signed distance between a selected value designated by x and the mean, which is equal to mu, divided by the standard of deviation. What we mean by signed distance, that means this distance can be positive or negative. But basically the z-value for any x, you take the distance between x and mu, the mean, and divide by the standard of deviation. So here is the formula is written. The z-value is equal to x minus mu divided by sigma. And the reason why we need this formula is when we calculate a probability for a normal distribution, we need to convert it first to z-value and then use the standard tables to calculate probability. Any normal probability distribution can be converted to the standard normal probability distribution with the following formula. The same formula that we calculate the z-values. In fact, if we start with x being any normal distribution, by subtracting the mean and dividing by the standard of deviation, you end up with a standard normal distribution. That's why this is a formula also to convert x values into z values. And now we know that x minus mu over sigma is a standard normal distribution, so we can use the standard tables to calculate probabilities for x. And here is an example of a table for the standard normal. The tables for the normal distribution are on the last page of the book. And you need these tables to calculate probabilities. This is just a portion of the z table, which there is several tables in the last page of the book. Let's see how this is used. If you look at the graph, this is a normal distribution. Mu is equal to 283. In the standard normal, when you convert this value to a z value, this is 0. This corresponds to 0. The x value we want to find the probability for is 285.4. When converted to a z value, it is 1.50. For the probability that x, the normal distribution value x, is between the mean, which is 283, and 285.4, is the same as the probability that z, the standard normal, is between 0 and 1.5. Now this probability of z between 0 and 1.5 can be obtained from the table. We want here, this is the probability from 0 and 1.5, 0. The z values, by the way, should always be rounded to 2 decimal places. In order to use the table, your z value must be rounded to 2 decimal places. So we want the probability, the probability from between 0 and 1.50 corresponds to the area under the curve, which is given by the table. The table consists of rows and columns. Look at the number 1.50. The first digit before the decimal and the first digit after the decimal, which is 1.5, this determines the row in the table that will give you the probability. So let's go to the table now and look at the first column. This contains z values. So I'm looking now for the row that says 1.5. Now the second digit will determine the column. The second digit after the decimal is 0, so we're looking for the first column. The area that we want is the intersection of the row for 1.5 and the column for 0. The intersection from the table is 0.4332. Then this area, the shaded area, is 0.4332. That means the probability that z is between 0 and 1.5 is equal to 0.4332. This is the same probability as x being between 283 and 285.4. So the process then to calculate probability for any random variable, the first step is always to convert the x values into z values, and then use the standard table to find the area which corresponds to the probability. طبعا we will look at several examples لأن the probability is always equal to the area, but we will see some situations where you're calculating probabilities where you may have to use the graph. It will tell you how to calculate the probability. But this is basically what the tables give you. The tables will give you the probability or the area from 0, which is the mean for the standard normal distribution, to any z value. In this case, it is the area between 0 and 1.50. And we will look at several examples to see how to use the tables. طبعا you should يعني do more examples. You should practice, لأن this is يعني using the tables takes some practice so that you get used to it. But there is no يعني the only thing you need to do is just make sure you read the table correctly, and that will give you the probability. يعني you can look up the probability by using the standard tables, which are in your last page of your textbook. Here now we will see examples how to convert x values to z values, and طبعا we will also see examples how to look up يعني probabilities using the standard table. This example that we will do, we will use it in several instances. This deals with the Uber taxi service. In recent years, a new type of taxi service has evolved in more than 300 cities worldwide. Here the customer is connected directly with the driver using a smartphone. It uses, there is an app that you have to use, the Uber mobile app. The way that it works is you can request to go to a place. So you submit a trip request, and they will طبعا there's a company will find the closest driver, and they would send them to you. And everything now is done using the mobile phone, including paying for the trip. So there is no cash involved because you request the trip. They would send you the driver. He would take you to your destination, and the payment is also collected electronically. Okay, this is the description of those drivers, and we're concerned now with the salaries, the income for those drivers. So here we're given the weekly income of Uber drivers follows the normal probability distribution, with mean equal to $1,000 and standard deviation equal to 100. That's what we need to know. First of all, the income for all of those drivers follow a normal probability distribution. We need to know two things, the mean and standard of deviation, which are given. The mean is equal to 1,000, and the standard of deviation is equal to 100. We will start by seeing how we can convert x values into z values, and later on we'll see how to use standard tables to calculate probabilities. The first one we will do is what is the z value? What is the z value of income for a driver who earns 1,100? The x value is 1,100. We want to convert that to a z value. طبعا always use the formula z is equal to x minus mu divided by sigma. This is equal to 1,100 minus 1,000 divided by 100, which is equal to 1.00. Remember now the z value, you should always write it rounded to 2 decimal places. Here is another z value. What is the z value of income for a driver who earns 900? Z is equal to x minus mu divided by sigma. This is equal to 900 minus 1,000 divided by 100, which is minus 1.00. طبعا the z value can be positive or can be negative. طبعا when we come back to using the tables is only for positive values, but because of the symmetry of the graph, the probability for negative values are equal. Just flip the graph and you will look up areas involving positive numbers. We will look at examples how do we find probability in case z is negative. Okay, now the z value for 1100 was 1. The z value for 900 was minus 1. The area between 0 and minus 1 is exactly the same as the area between 0 and 1. In both cases, the probability will be 0.3413. This is the area طبعا, which is equal to the probability. This you can find from the table. طبعا for 1, you take 1.0. If you look for the row that says 1.0 and look for the column that says 0, the intersection will give you the area. The intersection will be 0.3413. يعني as far as our problem is concerned, if you select a driver at random, the probability that he makes between 1000 and 1100 is equal to 0.3413. طبعا this is the same probability that the driver will be earning between 900 and 1000. And we will طبعا look at many examples how to calculate different probabilities. Here is now a rule that we know about the normal distribution. What it says for symmetrical bell-shaped frequency distribution, approximately 68% of the observations will lie within plus or minus 1 standard of deviation of the mean. And we will see what that means. So within 1 standard of deviation, you will have 68% of the area, or the observations. Now 95% of the observation will lie within plus or minus 2 standards of deviations of the mean. Yani if you take the interval from take the mean minus 2 standards of deviation and also the mean plus 2 standards of deviation, that interval will include 95% of the observation. And as far as area is concerned, it will include 95% of the area. Now if you go within 3 standards of deviation, that will give you most of the data. Practically all the data, 99.7, will lie within 3 standards of deviation of the mean. Here is the picture shows that. If you look at the first interval from 90, this is now for a distribution that have mean equal to 100 and standard of deviation equal to 10. If you go 1 standard of deviation to the left and right, and in the interval from 90 to 110, that's 1 standard of deviation from the mean, you have 68% of the observations, or the area. If you go from 80 to 120, which is within 2 standards of deviation, you will have 95% of the area. And if you go within 3 standards of deviation, and from 70 to 130, you will have most of the data, or you will have 99.7%. This is something we know about all symmetrical bell-shaped frequency distribution. This is certainly will be true for normal distributions. You can actually verify, this is called the empirical rule, you can verify it using the tables. Verify it for the standard normal distribution using the tables. For example, we know that for the standard normal, the mean is 0 and the standard of deviation is equal to 1. For z equal 1, that represents now 1 standard of deviation. This is 0 plus 1. The area from the table will be 0.3413. I think we did this one already. But this is only half of the area. This is the area from 0 to 1. The other half is from 0 to minus 1, which is exactly the same distance. If I multiply this by 2, you get 0.6826, or 68% of the area. For z equal 2, that is within 2 standards of deviation from the mean, the table will tell you this is equal to, by the way, for 2.00, you go to the row that says 2.0 and take the intersection of that row with the row that says 0. It will be 0.4772. That's the area, half of the area now, between 0 and 2. The other half is between 0 and minus 2. If I multiply this area by 2, you get 0.9544. Yani 95% of the area will be within 2 standards of deviation. For z equal 3, you're within now 3 standards of deviation. The table will tell you that the area is 0.4987. Multiply that by 2, you get 0.9974. Yani 99.7 of the area will be within 3 standards of deviations. Let's use the empirical rule in an example. As part of its quality assurance program, an Autolite battery company, this is a company that manufactures batteries, they conduct tests on battery life. Battery life have a certain expected life. How long will a battery last? So for a particular D-cell alkyne battery, the mean is 19 hours. This is the mean for how long the battery will last. The useful life of the battery follows a normal distribution with a standard of deviation of 1.2. For the life of a battery, either it is a normal distribution with mean equal 19 hours and with standard of deviation equal to 1.2 hours. Now, 68% of the batteries failed between what 2 values? You have to go plus or minus 1 standard of deviation. But this is 19 minus or plus 1.2, which is the standard of deviation. For 68% of the batteries will fail between 17.8 hours and 20.2 hours. 95% of the batteries failed between which 2 values? That's within 2 standards of deviation, 19 minus or plus 2 times 1.2. This will be between 16.6 and 21.4 hours. This is where 95% of the batteries will fail. Virtually all the batteries will fail between which 2 values? You have to go within 3 standards of deviation. So it's 19 minus or plus 3 times 1.2, and that's the interval 15.4 to 22.6. Most of the batteries will fail between 15.4 hours and 22.6 hours. This is just direct application of the empirical rule, since we know that the battery life follows a normal distribution. Let's go back to calculating probabilities, and we will do several examples because how you calculate the area which gives you probability depends on the problem, what probability you are trying to find. We have already seen an example of how to use the table. Let's do more examples. We always start with a z value. And we're back now to the problems for the upper drivers. So we already know the mean is equal to $1,000. That's their income. The mean is 1,000, and the standard of deviation is equal to 100. I think we already did this calculation. What is the z value of income for a driver who earns 1,100? Z, the formula, you take x minus mu over sigma. This is 1,100 minus 1,000 divided by 100, which is equal to 1.0. If I want to know that if I select a driver at random, what is the probability their income will be between 1,000 and 100? Well, this is the probability that z is between 0 and 1. The area under the curve from 0 to 1. فإن the table طبعا 1.00, go to the row that says, in this table to the left, go to the row that says 1.0 and also look up the column that says 0. The intersection is 0.3413. This is the area which gives you the probability. فإذا using the income, the probability that if you select a driver at random, the probability that their weekly income is between 1,000 and 1,100 is equal to 0.3413. طيب, what about the probability that their income, suppose I pick a driver at random, what is their probability? What is the probability that their income is 1,000 less than 1,100? طبعا that means if you طبعا look at the table, you want all the area to the left of 1.0, to the z value of 1.0. طبعا the table gave us the area between 0 and 1, which was 0.3413. Now you want a different probability. You want the probability that the income is less than 1,100, so you have to also add the area to the left of 0, يعني add 0.500. طبعا the total area is 1, and this is a symmetric graph, so the area to the left of 0 is equal to 0.50. Then the probability that the weekly income is less than 1,100 is equal to 0.3413. This is now the area between 0 and 1, plus 1/2, which is the area to the left of 0, which is equal to 0.8413. In many of these problems, to draw a graph will tell you how to calculate the probability. طبعا you always use the tables, but the table will only give you part of the probability. Sometimes, like in this case, we had to add 0.5 when we were calculating the probability that the income is less than 1,100. So we were looking at the area for values smaller than 1, but that includes all the area. The table only gives us the area between 0 and 1, so we have to add 0.5 to get the entire area, which will give us the probability that the income is less than 1,100. Let's do more problems. This time we'll see how to handle negative values for z. طبعا as we stated before, the key here, in a sense, you have a symmetric graph. طبعا the table only give you areas for positive z's, but because the graph is symmetric, for any negative value of z, just think of it, just flip the graph and the negative number will be positive. But again, you have to طبعا carry the calculations in the correct way to get the correct area. So let's do a problem that involves a negative value for z. What is the z value of income of a driver who earns 790? The z value, طبعا the formula x minus mu over sigma. This is 790 minus 1000 divided by 100, which is minus 2.10. طبعا if you look at the graph, if you want the probability that the income is between 790 and 1000, this is the area between minus 2.1, for z values, this is the area between minus 2.10 and 0. If you can imagine the graph, if the graph is flipped, this is exactly the same area between 0 and positive 2.10. And that we can find from the table. We're looking up now the area between 0 and positive 2.1. طبعا 2.10, for the row is 2.1. Look at the row which says 2.1 and look at the column that says 0. The intersection is 0.4821. Then the probability that the income is between 790 and 1000 is equal to 0.4821. If we want now the probability that the income is less than 790, since the total area to the left of 0 is 0.5, and we want the probability that the income is less than 790, معناتها we want the area to the left of minus 2.10. So take 0.5 and subtract the area between minus 2.10 and 0. If you look at the shaded area, if I subtract the area under the curve between minus 2.10 and 0, if I subtract it from 0.5, I get the small area which is to the left of minus 2.10, and that's what will give you the probability that the income is less than 790. It is then equal to 0.5000 minus 0.4821, which we looked up from the table. The probability is 0.0179. Here are more areas. In this example we'll also be adding probabilities, but the basic thing we do to look up the probability from the table, and then depending on the situation where we may have to add to get all of the area or all of the probability, sometimes you have to add two values. Let's do it now for this problem. We want the z value for income of 840. Using the same formula, z is equal to x minus mu divided by sigma. 840 minus 1000 over 100 is minus 1.60. The second number, we want the z value for an income of 1200. This is 1200 minus 1000 divided by 100 is equal to 2.0. Now if we want the probability that the income is between 840 and 1200, we have to break up the problem into two parts and use the table and add the two probabilities. If you look at the graph, the area, the probability that we want in income is between 840 and 1200. We have to break it up into two parts. First, we want the probability that the income is between 1000 and 1200. As far as the z value are concerned, this is the area from 0 to 2, which you can look up in the table easily. You have to add that now to this left half, which is the probability that the income is between 840 and 1000, which is the area between minus 1.6 and 0. The area between minus 1.6 and 0, using the tables, you have to look up it up for 1.6, the area between 0 and 1.6, and that's the same area because of symmetry, the area between minus 1.6 and 0. The other one, the area between 0 and 2, this is just a straightforward. You can look it up from the table. Now we are ready. Now that we know the two parts of the probability, the two areas, we can just add them together. Then the first area, the probability that the income is between 840 and 1000, this is the area to the left of 0. It's equal to 0.4452. The area to the right is the probability that the income is between 1000 and 1200. This is the area between 0 and 2, which is equal to 0.4772 from the table. Now the probability that the income is between 840 and 1200, this is the sum of those two probabilities. So it's equal to 0.4452 plus 0.4772, which is equal to 0.9224. Here is another problem. What is the z value of income for a driver who earns 1250? As usual, you want to subtract the mean and divide by standard of deviation, and that will give you 2.50. Second question, what is the z value of income for a driver who earns 1150? And using the same formula, subtract 1000 divided by 100, you get 1.50. Now what we want to do is we would like to see the probability that the income will be between 1,150 and 1,250. For the z values, you want the probability that z is between 1.50 and 2.50. If you look now, always the graph will help you decide what to do. This is just the shaded area. طبعا the tables, you can look up the area from 0 to 2.5 and then subtract the area from 0 to 1.5. يعني the shaded area is simply the area between 0 and 2.5 minus the area between 0 and 1.5. And both of these values you can get from the table. Starting with the larger area, the probability that the income is between 1,000 and 1,250, that corresponds to the z value 2.5. The area will be 0.4938. The smaller area, which is between 0 and 1.5, this is the probability that the income is between 1,000 and 1,150, and that's equal to 0.4332. Now the shaded area that we want is the difference. If I take 0.4938 minus 0.4332, you get 0.0606. This is the shaded area. This is a probability that z will be between 1.50 and 2.50, which is the same probability that the income will be between 1,150 and 1,250. So as you can see, the graph will help you decide what to take. And sometimes you're adding area, sometimes you're subtracting. This all depends on the probability that you're interested in. And even when you break up the problem into two parts and then end up with adding or subtracting, in each step we do it in a way that we can use the table, use the z tables to look up the probabilities. But the graph will help you decide whether you need to add or subtract, and what to add or subtract. The area, drawing a graph will help you how to use the tables, the standard tables, to look up areas. Let's do طبعا احنا so far we have the x values. We start with the normal variable x, and to find probabilities we convert the x value into z values and then look up the probability or the area using the standard table. Now what about the reverse process? Supposing you know the z value but you want to convert it to x value. You want to know the value for x if you know the z value. So here is a problem that will explain that. In this problem we have a tire company. Leighton Tire and Rubber Company wishes to set a minimum mileage guarantee on its new MX100 tires. طبعا companies that sell new tires, they have to give a warranty. فطبعا the warranty, they should know what to expect, how long the tire can be driven before it gives out. If you don't want to give a warranty where you end up with having too many customers come back to make a claim, the warranty is set based on what is the expected value, how long will these tires last, how long can you drive those tires before you have to replace them. Okay, for these tires, the test, as many things that involve manufacturing, this involves running tests on the tires. For the test revealed that the mean mileage is 67,900 miles. On average, these tires can be driven for that long, 67,900 miles, before they're worn out. Then the mean is 67,900. Standard deviation is 2,050 miles. Here طبعا what we also know in This data follows a normal distribution. We already know the mean and standard deviation. For now we can do some calculations. For X represents the minimum guaranteed mileage. Okay, for X represents the minimum guaranteed mileage, and we want to use the formula for Z to solve and find the value for X, so that no more than 4% of the tires need to be replaced. What that means, now we want most tires to last long enough, and you don't have too many people needing tire replacement, and therefore طبعا under the warranty the company would have to replace those tires. So here you know the Z value and you want to calculate the X value. Now what is the Z value? We want no more than 4% of tires need to be replaced. The X values which we will figure, the area to the left of that number should be 4%. 96% of the tires now will last longer than X and therefore will not need to be replaced. Only 4% are under this value of X, so that you would not have to deal with too many people with tires needing replacement. فإذا what we want to do is we want to look, first of all, we can look up the Z value that will give me an area equal to 4% or 0.04 to the left of Z. That you can do from the table. And then once you have the Z value, you can convert it to X value. Now 4%, that means طبعا the area from Z or from X to the mean must be 46%. 0.46. So we want the Z value that will give me an area equal to 0.46. Okay, for 0.46 here, now you use the table in reverse. So what you want to do is look up an area as close as possible to 0.46. The table will show that the closest number to 0.46 is 0.4599. But this is the area that we want. So what is the Z value that corresponds to this area? Well, you look up the first two digits from the row number, which is 1.7, and the column number here is 0.05. For the Z value that will give you that area is 1.75. 1.75 will give you an area of 0.4599, which is very close to 0.46. For the Z value that will give us the required area is equal to 1.75, but we are interested in X, the value for X, the miles that the company will give as a warranty to guarantee in no more than 4% of tires will be replaced. If you know the Z value, then using the same formula you can find the X value. The Z value equal to X minus mu over sigma, so it's equal to X minus 67,900 divided by 2050. So you can solve this equation for X, multiply, for example, multiply Z by 2050 and add 67,900, and that will give you the value for Z. By the way, طبعا the table told us Z is equal to 1.7, but we know it's a negative value, and the table gives you the positive value. But it is very clear from the drawing, and we should take the negative value. Now the Z value is minus 1.75. Substitute that value for Z, minus 1.75 is equal to X minus 67,900 divided by 2050. Now solve for X, multiply both sides by 2050 and add 67,900. X will be 64,312. فإذا this is the X value that will guarantee you in the 96% of the tires. If you give a warranty for this number, then you know in the 96 of the tires will last that long, يعني will not يعني be worn out, will not fail before this number. So then under 4% of the tires might fail and might the company might need to replace them under the warranty. Then this is the value X where the warranty should start. Okay, I think this is the last slide, but your next quiz cover, I think will include chapter 6 and 7. There will be more than one problem about the standard distribution. But when you take the quiz, you make sure that you have the normal tables because you need them to solve problems. It is also advised, especially if you're not familiar with the normal distribution, and then you should do more problems, do more exercises from the book, especially the solved examples. You need to practice using the tables. This is a skill, and for you to learn a skill, you need to practice. Now we did a few examples, but I think it would be a good idea for you to do more examples. And okay, this is the end of this tutorial.